Hello, this is Dr. Mears. Today we are going to be problem solving using Venn diagrams. So this first problem you've seen before, and I'm actually introducing the notation again to make sure that you understand the difference between when you're looking for the numbers in a set and when you're looking for how many numbers there are in the set. So let's go. Example 1, our universal set, which means all the numbers 4, 5, 6, 7, 8, 9, and 10. Then we have set F, which holds 4, 5, 6, and 7, and we have set G, which holds 6, 7, 8, and 9. The first thing to do is draw a Venn diagram, and it's really good to draw a Venn diagram all the time. It helps you organize your numbers. That's what a Venn diagram is. Okay, so let's draw the Venn diagram. Here's our universal set, so all those numbers are going to be inside. Here's F, and here's G. And so when you draw the Venn diagram, remember, always start in the center spot. So always make sure that you know the numbers that F and G share. So let's go see what numbers they share. So in F, I see that we have 6 and 7, and in G, I see that we have 6 and 7. So those are the numbers that go in the middle. Then let's look at set F, what's left over. 4 and 5 are left over, and here 8 and 9 are left over. Now let's check our universal set to make sure we have all the numbers because there might be some that don't belong to both of those. So that would go on the outside. So we have 4, 5, 6, 7, 8, and 9. The one that we're missing though is 10. Okay, so we're ready to go with answering these questions. Okay, first one, we need to write down the numbers in set F. Actually, look at that little prime right there. That's a little complement symbol. That means not in F. So remember that little apostrophe means not. So we have to look at the numbers not in set F. So if I take my finger and put it over set F, so I need the numbers not there, which is 8, 9, and 10. 8, 9, and 10. Now I'm going to go here. This is requesting for you to write down the number of elements. So remember this N right here, this means number of elements. So it wants you to count how many numbers you have. So basically I have 1, 2, 3. I have 3 numbers not in set F. Okay, next, F and G. F and G is and. It has to happen F and G at the same time. And so F and G at the same time is basically where we started, right in the middle. These are the two numbers that they share. So in F and G are the numbers 6 and 7. So the number of elements in F and G, there's 2. 1, 2. Next, we have F and not G. So F and not G. So we're going to look back up here. Okay, so here we have the circle F. Okay, but it can't be in G. So I am going to block out F and not G. So the numbers that are left in F are 4 and 5. So 4 and 5. Okay, next, how many elements are there in F and not G? And I can count, there's 2. Okay, now we have F and G, but we have the complement of that. And the complement of F and G meaning it doesn't belong in F and in G at the same time. So it cannot belong in F and G at the same time. So if we look, let's first just go back to F and G. F and G were 6 and 7. Okay, so it cannot be those two numbers. So what numbers are left? 4, 5, 8, 9, and 10. So that's what we write down. 4, 5, 8, 9, and 10. So the complement of F and G, we looked at 6 and 7, can't be that. So the numbers that are left were 4, 5, 8, 9, and 10. We count them up to find the number of 4, 5, 6, 7, 8, 9, 10. So there's 5. 1, 2, 3, 4, 5. And the last one for this one, this is F or G. This is the inclusive or. It means one or the other or both. And so how I can best describe this is doing a little shading. So for F or G, it could be an F. So this is just F right there. So we can have the numbers 4 and 5. It could be a just G. Just G is 8 and 9. So 8 and 9. Or it could be in both. And both is 6 and 7. 6 and 7. So it's the numbers 4, 5, 6, 7, 8, and 9. So at each of these parts, basically both circles, that's your one or the other or both. Counting these numbers up, I have 5. 1, 2, 3, 4, 5. Ooh, 6. Good thing I recounted. So there's your 6. 1, 2, 3, 4, 5, 6. So there's your 6. So this has been a little bit of notation, reviewing the difference between when they want the actual numbers written down and then when they want the number of elements. Now it's good because the thing is, the number of elements here, this is what we're actually going to be using from now on. So we're going to be switching from finding what numbers are located in the set to actually finding the number of elements, and that's it. So we are going to be working with this side more often. Okay. Next one, example 2, which is the last example that we have. Example 2, we have 16 students that study French, 11 students that study Malay, 4 students study neither, and we have a total class size of 25. The first thing that they want you to do is make a Venn diagram. Okay, so here's our universal set. This is our entire class, so all 25 students. This is going to be French, this is going to be Malay. So where did I say to start? I said start in the middle right here. However, the middle means both. Is there anywhere that they say both here? So that's pretty, that there's no both. Well, let's see what we do have. We have 16 students that study French. So I'm going to write this down here. 16 students that study French. So this goes back to our problem where we had it was the contradiction problem that we first started with, where she asked the students to raise their hand, and they raised their hand and said, okay, well, 16 students study this, 11 students study Malay, and 4 students study neither. So let's see what this adds up to. So this actually adds up to 31, but the total class size, she remembers, was 25. So this is like that contradiction problem. So something is happening here. We're coming out with more students than we actually have. And you guys definitely figured it out that we do have some students taking both. And so the number that are taking both, let's just subtract the difference here. So we have 6, or not subtract the difference, let's just subtract 31 minus 25. So we have 6. So this is the number of students that study both because there's that overlap there where they would be raising their hand twice. So now we have how many students study both, which is going to be 6. And from this 6, 16 study French. So we cannot put a 16 here because this whole circle should be 16. So we can't put 16. We actually have to put 16 minus 6, which is going to be 10. So 10 students study French. Now Malay, here's the whole Malay circle. We know the whole circle is 11. 6 of those 11 students study both. So we can't put 11, we got to put 11 minus 6, which is 5. So now we have this, just studying French is 10, studying both is 6, and just studying Malay is 5. Let's not forget our neither students that study neither, which is 4. If you add 10, 6, 5, and 4 now, that should give you the correct total. 10, 6, 5, and 4. Let's add those up, and that does equal 25. And so we are correct. Okay, let's use our Venn diagram to flip our paper over, and when you flip your paper over, we're going to have these questions. I actually got 2 papers here so that we can use the Venn diagram. Okay, part B, how many students study both French and Malay? Oh, perfect, we have that. That's where they intersect, which is at 6, so 6 students. Nice, okay. Part C, write down the number that study. Let's do this. Okay, Malay only. So we're going to go to the Malay circle. Malay only is 5, so 5. All right, exactly one language. Let's see, exactly one. So we cannot have this both because this is 2, correct? So exactly 1. So we know that 10 students study just French and 5 students study Malay. So that gives us 15. And you know what? I'm going to write students after this. I always like to write some type of unit. So 15 students study exactly 1. Okay. How about at least 1? At least 1 means, well, it could be 1 or more. So we know that 10 students study just French, so that's 1, at least 1. 6 students study both, that's fine, and 5 students study Malay. So if we have those together, we're going to get 21. So 21 students study at least 1. Okay, let's see, what's next? Do not study French. Okay, do not study French. So here's the French circle. Do not study French. Here is the French circle. So we have the people that just study Malay, and we have the people that study neither. Do not study French. So we have to do the 5 plus the 4. So we have 9 students that do not study French. They either study Malay or they don't study either one. Okay, how about do not study Malay? So we have Malay. We have the 6 that study both, and we have the 5 that study Malay. So we have 10 that study French, and we have 4 that study neither. So we have 14 that do not study Malay. French, but not Malay. French, but not Malay. So here's our French. We have 10 that just study French. We have 6 that study Malay too. So they're just looking for that 10. That's basically just French. Okay. French or Malay or both. So this is that or question, inclusive. So we have French, which is the 10, or we have Malay, which is the 5, or we have both, which is the 6, and that's going to give us 21 students. And the last one, French or Malay or but not both. Ooh, French or Malay but not both. All right, so just French is 10, just Malay is 5. We cannot have both, so that's going to be 15 students. And there we go. So this has been problem solving using Venn diagrams. We are now getting into total counts here that we are going to be extracting from our Venn diagram to answer our questions. I hope this helped. Work on your DCCs.